I'm Hanish Patel, and this is User Friendly, the show where we explore emerging trends in tech, media, and telecom, and how they impact business, operations, and the world around you. In 2022, the global semiconductor chip industry is expected to reach about $600 billion, driven by the increasing need for chips in everything from cars to appliances and factories. And with the proliferation of consumer and manufacturing products, chips will just continue to grow in importance. On today's episode, we'll discuss how the semiconductor industry is managing the continued demand for chips, challenges such as supply chain disruptions and talent shortages, as well as the opportunities for growth in the future. Joining me to discuss the trends impacting the industry and the implications for TMT companies are Christy Simons, Audit and Assurance TMT Industry Leader at Deloitte, and Duncan Stewart, Director of TMT Research at Deloitte Canada. Christy, Duncan, welcome to the show.
Great to be here.
Thank you very much.
So let's just dive straight in. I mean, the chip shortage of 2020 and frankly 2021 really brought semiconductors to the fore and established their place as truly essential to so many parts of our lives. So I want to open up in a bit of a sort of two-part question, if I may. And that being, firstly, Christy, can you explain why we're seeing this level of demand from consumers, companies, and governments? And then Duncan, what is the impact this will have on the semiconductor industry?
Sure, Hanish. Semiconductors, or chips as we call them, really power every aspect of our lives, which is exacerbated by COVID as everyone, migrated work and school into their home. And we saw that the demand for technology really resulted from that migration. I mean, one can look at your desk and your home and imagine the number of chips that are within your environment. You think about your laptop, your phone, your printer, the car you drive, if you wear a smartwatch, many of the appliances in your home, the temperature gauges, remote controls, TVs, maybe even a new refrigerator or washer or dryer, and definitely, the new digital sports equipment that you might have purchased during COVID. All of these, quote, things really can't operate without a chip or even multiples of chips. So, we've seen that chips have actually become even more important now and probably will be over the next 20 years than what they've been in the last 20 years as, all of us and consumers really lust for more technology and actually want technology to do even more, which is probably going to require even more chips being used in our devices, as well as creating chips that are even more efficient. So that's really what's fueling the demand and the, quote, shortage that we hear about in the news almost every day.
Just to chime in with what Christy said, this is really much more about demand than about supply. I mean, normally when we have a shortage of something, whether it's coffee or corn, it's because, there was a drought or the crop failed and there wasn't enough stuff there. It's not that everybody started drinking more coffee. The chip shortage of 21, 20, and maybe even 2022 looks like it's more on the side of crazy high levels of demand. As an example, you started off the podcast by saying that global industry is going to be about $600 billion in 2022. That's up from $400 billion in 2019. This industry is 50% larger than it was 3 years ago. So the industry is doing the best it can to keep up with hyper growth in demand. And that's actually being manifested in a rising percentage of GDP. When you take a look at the chip industry from where it was 30 years ago, every decade or so, it keeps getting bigger and bigger as a percentage of global GDP.
Thinking about what you both said there, Christy, as you mentioned, the demand for the next 20 years versus what we saw in the last 20. And Duncan, as you've just highlighted, just that 50% growth literally in the last 3 years. So if we think of it from that perspective, as demands for chip just continues to grow, what can companies, governments, and frankly, the players in the semiconductor ecosystem do to meet that demand and actually help reduce the severity of future shortages like the ones we're experiencing right now?
What an Excellent question. I wish I'd written a paper about. Oh, wait, I did. So Deloitte actually published an article called Five Fixes for the Semiconductor Chip Shortage, which I wrote with some colleagues. And we talk about five things that can be done, need to be done, are being done by chip makers, distributors, customers, and governments. The first one is building overall capacity around the world. That's going on, but that takes a couple of years and hundreds of billions of dollars. The other thing, though, and this is more new, is more local capacity. Historically, the chip industry has been highly concentrated in East Asia, and around the world, governments, companies, buyers are saying, no, I want more chips built close to me. Now, that's growth in the US, but also in Europe, in Mideast, in Singapore. One of the other things that can happen is that the industry can perhaps focus a little less on just being lean. Instead of just trying to drive inventories and so forth as low as possible, maybe build in a little more buffer to the system. The other thing is what we call breaking the bullwhip. The bullwhip is this thing in the supply chain where a lack of transparency between layers of the different parts of the supply chain, that lack of visibility means that small perturbations end up being exaggerated by the end. So tiny little gaps in information sharing can lead to much bigger shortages. The final thing that can happen is that companies, especially chip companies, can embark or accelerate digital transformation. I think Christy has some thoughts on that.
Yeah, that's right, Duncan. And digital transformation within semiconductor companies is happening currently, and it's going to continue to accelerate. And what do we mean by digital transformation? A lot of it is key operational transformation within manufacturing of these companies, or the IT organization, or other business functions. Really figuring out how to do more with the same resources or even less in order to stay cost competitive, in order to, help with some of this demand and providing additional supply. So we're seeing clients look even at new markets and even new go-to-market strategies to create new revenue models as they think about how to meet some of this demand and some of these new offerings, and even providing, something as a service and integrating solutions on a chip to do more in a smaller package, which is also real transformation of an industry, that's really been around for 40 years or so. We did partner with the Global Semiconductor Association on a survey that noted that nearly 3 out of 5 chip companies have already begun their transformation journey. And yet over half of those are modifying their transformation process as they think about manufacturing, which is really in response to some of the changes that we've seen in the market during COVID and also the increased competitive pressures.
I want to dig in a bit more about what you've mentioned there, Christy, right, in terms of how they're on that transformation journey and the changes that are making. And no doubt that's going to require investment. That's going to require some change. And Duncan, you mentioned about a POV. So I'm actually going to bring one up around a prediction that Deloitte actually put forward, that we put forward, that venture capital firms are globally going to be investing more than $6 billion in the industry alone in 2022. Mm-hmm. Do you see a big reason for that investment around that transformation, or is there other focus or efficiency or all of the above that you're seeing where that investment's likely to go?
I love this new stat as we think about venture capital investments into startup semiconductor companies, because that is something that has really not happened in the last 20 years. And so as we think about the transformation of the industry, what we're really seeing today is that venture capital investments into companies that are thinking about how to design better chips that are more secure, that are faster, maybe more energy efficient. Also, the newer designs of new and existing chips. As you think about, human beings are really engaging more and more with technology. There's going to be an increase in demand for the functionality of these chips. And we want our technology to do more. We want it to be more secure. We want it to move faster. So I think that's really what's going to fuel a lot of these startup companies And these startup companies are fabless semiconductor companies, which really focus on the design of the chips. They don't necessarily do the manufacturing of the chips, which is what you hear a lot about in the news today and some of the supply chain shortages. It's really pretty sophisticated technology and allows startups that typically have a lot more agility than some of the larger chip companies and can provide development of some of the niche applications and some of the chip enhancements that I mentioned. They can provide that in a much more timely and more quickly than maybe some of the larger companies. In addition, there's some new design architectures out there making it easier for startup companies to design chips. And the RISC-V architecture Duncan is very familiar with. So I'm just going to let him talk and give a little bit more description about this exciting new architecture that's out there.
So actually, firstly, thank you for that. And Duncan, before you jump in on that, RISC-V, let's break that down for our listeners, if you could.
So it's a board game you play where you take over. No, it's not that one. RISC-V is an instruction set architecture in ISA, and people's eyes always glaze over the second I say ISA. It's simple. Do you have a laptop? Do you walk by a data center? Inside there are a bunch of chips with processors that run on an instruction set architecture or ISA. And inside computers or data centers, those are mainly the x86 ISA. Meanwhile, in our smartphones and tablets and a lot of other smaller devices, we've got the ARM ISA. For both of those markets, those two ISAs, which are closed and proprietary and cost money, at the end of the day, most of the processors that people are going to run into run on one of those two. RISC-V is a third open source ISA. It's been around for a few years, but it's really taking off now. A quarter of all new chip designs in 2020 actually were built on the RISC-V ISA. The number of cores, the dollar value, this is a market that's growing at well over 100% per year.
Brilliant. And thank you for that description around that. You both highlighted the significant growth and where it's going and new architectures that are brought in. I want to pivot slightly, right, in terms of what some of the impacts of that we're actually seeing in the industry. And certainly one of the biggest challenges that I think just about every industry is facing right now is the talent shortage. But despite this being a widespread concern, and rightly so, are there specific issues that are really impacting the US chip companies when you think about all this growth, think about incredible amount of demand that's being put on them? What are those specific issues? I'd love to dig into that. And Christy, if you could kind of discuss some of those and how companies can maybe even help address some of those challenges that they're facing.
Sure. Happy to share some thoughts. Obviously, the ongoing talent shortage has even been made more severe with the increased semiconductor manufacturing facilities that are being built in the US that we hear about as well. And even in other countries that are outside of Taiwan, China, and South Korea. These new fabs that are being built are going to need thousands of experienced workers. And it's not going to be just the recent college grads, but those workers who've really got experience with complex manufacturing. And what I find really interesting about this is that we've essentially come full circle. You think about 40 years ago when semiconductor industry was started, the early manufacturing of these chips in the 80s was in the US and then was moved to Asia to reduce cost. And along with it, the manufacturing talent has been developed in Asia for the last few decades. So there's definitely going to be a need in the US for additional manufacturing talent capabilities. Also, you think about competition for this talent from other technology companies who are aggressively expanding in high growth areas like AI, edge, robotics, 5G, smart devices. All of these industries are adopting technology, which is also increasing the demand for much of the same technology pools. And what's interesting today about the demand for talent is the software skills that's going to be needed in order to program and integrate some of these chips into the markets for electric vehicles, robotics, home automation, AI that I mentioned and 5G, as well as, shift from fossil fuels to green energy. Some of that's going to further exacerbate the shortage of labor and the needs. Our TMT Semiconductor Outlook actually noted that revenue specific to EDA software is anticipated to double from 10 billion in 2020 to almost 19 billion by 2027. So essentially, those software skills as well as the manufacturing skills is really going to fuel a demand for talent. So, if we think about the demand for talent and the future of the workforce, companies can proactively engage with high schools, with junior colleges, universities to advance the STEM program and to advance the STEM skills of graduates and bolster some of the innovation, as well as tapping directly into some of the international alliances and ecosystems that are out there. The third thing to think about is just nurturing the talent with benefits and initiatives, foster greater collaboration between the core manufacturing, the technical abilities of the design, R&D that can cater to the hybrid work model. We see a lot of people who really want that hybrid work model and being able to work from home and work on site, but being able to adapt the industry to that work model is really important as well.
Thinking about what you said there about some of the, I'll call them opportunities for these companies to evolve when they're considering the talent shortages and the focus around talent, and rightly so. And I think as they continue to become more agile and continue to meet demand, sustain their competitive advantage in the future, what are they specifically doing when it comes to really increasing their commitment to environmental issues such as sustainability? And I ask that because earlier we talked about efficiency of the chip itself. And you touched upon kind of moving from, say, fossil fuels to green energy. So I'd love to get a sense of what they're doing and where they need to go. And specifically, Duncan, is the industry really meeting those expectations, or do they have ways to go?
Well, I mean, it's always a journey. You can always do better. The industry needs to do better, is doing better, and is making significant gains. One of the problems is that about a year ago, there was this article that was published that kind of went viral. And a lot of people quote this one at me and they say, isn't the chip industry using an awful lot of power and therefore producing an awful lot of CO2? And so what I did is the major companies, the big three, actually disclosed in 2020 their annual CO2 footprint. And I added up A and B and C, and it's 31 megatons. And oh my gosh, 31 megatons, let's shut them all down, right? We're destroying the planet. And then I looked up the global emissions for the year, and it's 36 gigatons, which means that the three largest chip manufacturers in the world's combined carbon footprint is 0.09%. So not 9%, but 0.09%. So could the industry do better? Yes, and they are. However, I really think that, Christy talked about how chips are found at the heart of almost every product these days. For an industry that is growing as fast and is as important as the chip industry to be less than 0.1% of the global CO2 footprint, I think means that we really need to put their contributions to global climate change in the right perspective.
This is absolutely top of mind of a lot of these large semiconductor manufacturers. When you think that, millions of gallons of water is actually used in semiconductor manufacturing, there's a focus that these large fab manufacturers need to innovate the actual manufacturing process or the fab process to reduce the amount of water usage and to also maybe even be able to recycle the water that is used. And the same holds true for the energy that's used for the equipment to manufacture these chips. You highlighted a little bit, Duncan, about the CO2 emissions because of the energy that's used for that. But I think as they look at energy efficiency, as they look at the number of chips that are being used in devices, is there a way to put more systems and more software on a chip rather than have multiple chips in a device? Can you have a chip have more functionality, which also goes to the sustainability and the efficiency that can be done in the manufacturing process?
So that answers the environmental side of it, right? Christy, from a social perspective, and let's specifically say diversity, equity, inclusion, is the industry making strides in the right direction?
Yes, I think they are. It's historically been a pretty male dominated industry, but I think DE&I is a topic really for every industry and for every company. And it's not only important to increase gender diversity, but also racial diversity. So we mentioned some of the STEM programs in high schools and colleges and how important that is to not only get the future engineering talent that's going to be needed to fuel some of this growth, but it's also going to increase the diversity of talent in the industry. When you think about the generation of millennials and Gen Zs, stats would say that that's the most diverse generation in history. So really to nurture and mentor and inspire that next generation to the semiconductor industry is going to be very, very important. But then also mentoring and sponsoring women and people of diverse backgrounds that are currently in the industry to take on some leadership roles within these organizations is also going to be very important.
I want to anchor in on the innovation part. And you kind of touched upon, like, say, from a talent perspective, but also the design of chips, the manufacturing. And if I think of innovation, certainly I think about just what recently happened at the Consumer Electronics Show. And unfortunately, this is the second year in a row that I didn't make it, but certainly from a decade of visiting in prior years, I know there's a lot of innovation and a lot of tech on show that's really reliant on semiconductors. And Duncan, I remember seeing your summary of CES, so thank you for that. That was super insightful. Really felt I was there without being there. But for our listeners, any insights from, say, this year's show or indications on where you see the industry headed based on what you saw at CES this year?
So let's start with the thing that you said, or that we've been actually talking about this entire conversation. Chips are at the heart of everything. So let's just start with that. CES is all about chips, if you think about it at that level. Which kinds of chips for which end markets? Auto. Wow, did we see a lot of automotive technologies, screens in cars, technology on the outside of cars, technology to make us safer. Big impact there on the whole automotive space. People have been using the phrase for a few years now that cars are increasingly becoming smartphones on wheels. Well, it's kind of come true in 2022. Hundreds of dollars of chips in cars on average, and in higher value cars, probably thousands of dollars of chips. More and more screens, smarter screens, curved screens, lots of semiconductor technology behind that. But the one that jumped out at me was healthcare. We actually have a prediction in our 2022 TMT predictions around wearable devices. These are smart watches and smart patches, not counting how many breaths you take or how many steps you take in a day, but diagnosing very, very serious medical conditions like atrial fibrillation, blood glucose, blood oxygenation, blood pressure. We're seeing 320 million of those devices, and we saw that at CES for the first time ever. A major healthcare company gave one of the keynotes. So those were sort of the chip highlights for CES for me this year.
Firstly, thank you for that. And, I could absolutely geek out at CES, and we could probably do multiple episodes on this. But to contain myself, I'm gonna try and close out the episode with a question to the both of you. And what I really want to know is, what excites you the most about the future when we think about the semiconductor industry and chips and the future and what it looks like?
I actually am pretty excited about the semiconductor industry and where it is. I've been playing in this market at Deloitte for almost 30 years now, and it's now cool to be in semiconductor. I think the chip shortage has really increased the visibility of the semiconductor industry overall. When people aren't able to get the devices that they want because one or two chips isn't available. I mean, we saw that with the automakers, right? That cars are in a supply shortage, and it's because the number of chips, you talked about it, Duncan, at CES, right? The number of chips that are going to be used in cars now, if you're missing one or two, you can't ship the car. You can't get it off the assembly line. And so that has really increased the visibility, I think, of the importance of chips to our economy. I've heard it said that semiconductors are the new oil in the digital age as semiconductors become more critical to really fueling our economy with technology. So that's really what excites me about the future. There's just a lot of opportunity here. There's a lot of excitement. There's going to be a lot of new products because of the semiconductor industry. So I just find that it's going to be a really exciting time for years to come.
So, Hamish, you said you wanted to geek out, and your wish is my command.
Let's do it.
I think
we can all geek out, yeah.
One of the coolest things that's happening right about now, and I'm going to be writing a prediction about this for 2023. Historically, the chips that have been in space, that up there in satellites and on spacecraft, have been very, very limited in capacity because of the harsh environment in space. The average computer that's on a spacecraft these days is about as powerful as a 1970s pocket calculator. I exaggerate, but only slightly. In the last little while, there has been remarkable progress at creating space-based computers that can actually do the processing hundreds of kilometers or thousands of kilometers up. Why does this matter? Because that is what we call edge processing. And it will be edge processing at the edge of space. And by doing that, you can enable all kinds of amazing functionality by doing the processing up there. You don't need to capture the data, send it down to Earth and then back. Instead, you can do the analysis and the machine learning and the AI, all of that rocket science, if you will, at the edge of space. And I think this is just it's so new, we really don't know how important it's going to be, but I think it's one of the most exciting things that I've seen in the chip industry in the last year or two.
Wow, I love that. Calculations in space. I mean, just to kind of summarize it out, and I think you put it really nicely as well, the both of you, in terms of an industry that's, 40 strong years, right? And for those who've been close to it, it has been a cool industry, but Christy, you said it's become seriously cool now in terms of just what it can achieve and what the future looks like that you articulated there, Duncan, about, space calculations. And I think it's, as we said up the top, it was really brought everything to the fore for us all with the increase in demand and the sheer demand that's going to continue to grow. This is definitely an industry to watch and observe and see how it continues to evolve to make things faster, make things more energy efficient, to frankly meet the demand that we all have as consumers for these devices, for the products, across manufacturing, across appliances, and just personal consumption. So a phenomenal discussion. Thank you both for coming on and helping our listeners better understand what's going on in the industry, some of the challenges, and what the future really looks like. So I want to thank the both of you, Christy and Duncan, for joining me today. And until next time, happy listening.
Thank you very much.
Thank you.
Thanks for listening to User Friendly. To subscribe or listen to more episodes, search for Deloitte User Friendly in your favorite podcatcher or find us online at userfriendly.deloitte.com. If you like what you hear, please rate us on Apple Podcasts and leave a review. The opinions expressed by guests on this podcast belong to them and do not necessarily reflect those of Deloitte. This podcast should not be deemed or construed to be for the purposes of soliciting business for any of the companies mentioned, nor does Deloitte advocate or endorse the services or products provided by these companies.